Let's review platelet production, distribution, and function. Platelets are produced from large precursor cells known as megakaryocytes. About 1/3 of platelets are stored in the spleen. The remaining 2/3 circulate in the peripheral blood. The normal reference range is between 150,000 and 400,000 platelets per cubic millimeter. The typical lifespan of a platelet is approximately 9 to 12 days. The primary function of platelets is the initial arrest of bleeding and the formation of a platelet plug. First, we have adhesion. Here, glycoprotein 1b on the platelet surface binds to exposed collagen. This process requires von Willebrand factor. As a result, platelets release ADP and other granule components, including factor V and fibrinogen. Second, we have aggregation. Other platelets are stimulated by ADP to undergo a shape change, from a flat disc to a sphere and finally to pseudopods. This change exposes the glycoprotein 2b/3A complex, which binds fibrinogen. This is the same complex targeted by GPIIb/3A inhibitor drugs. Fibrinogen bridges link the platelets together. This is the first phase of aggregation, and it is reversible. With weak stimuli, platelet aggregates can fall apart. With strong stimuli, however, the platelets release more substances, and at that point, aggregation becomes irreversible. The bottom line: after adhesion and aggregation, a platelet plug is built at the injury site. The platelet function assay, or PFA, essentially asks, do the platelets properly adhere and aggregate at the injury site? Next, we move to localization of the platelet plug. Secreting platelets release arachidonic acid. Within the platelet, this is converted into thromboxane A2, which promotes platelet activation. In contrast, adjacent endothelial cells process arachidonic acid into prostacyclin, which inhibits platelet activity. The bottom line? The platelet plug is restricted to the site of injury and does not spread uncontrollably. Finally, we consider the assembly and localization of the fibrin clot. Platelets release fibrinogen, factor V, and factor VIII. During aggregation, fibrinogen binds to the platelet surface. Factor VIII also binds to the surface, stabilized by von Willebrand factor. As the platelet changes shape, phospholipid is exposed on its surface. This phospholipid acts as a template for clotting factor complexes. Historically, it has been called platelet factor III. It binds the factor VIII and factor IXA complex in a calcium-dependent process, which explains why hemophilia A and hemophilia B produce clinically identical bleeding disorders. It also binds the factor V and factor Xa complex, again requiring calcium. The bottom line: the platelet plug provides the perfect surface for fibrin clot formation. Without platelets, fibrin cannot form efficiently. Platelets therefore both promote and localize clot formation.